Welcome everybody. I hope everyone is focused because the talk I've got to give today is a lap around an 8-year-old payments company Codebase, and it is unfiltered, unfettered. We're going to literally boot up Visual Studio, though I did that before because it takes about 10 minutes. And we're going to dive into actual code. So you're going to have to bear with me because I've got some simple examples to begin with, and then we're going to dive into the actual code, and it's going to be a little bit tough to follow. So if at any point you're like, hey, slow down just for a second, please just raise your hand and I'll take my time a little bit more. But I'm actually really excited to be here specifically at DDD Melbourne as the headline sponsor. It's a fantastic privilege and opportunity because it was about 8 years or so ago that I started this business, Pinch, with a co-founder in Brisbane. But it was a lot earlier than that. It was in 2011 when I went to my own first DDD. This was in Brisbane, but it was fresh out of uni. It was brand new to us. We didn't know what was going on, but it was affordable. So as poor uni students, we could go along, and it was at my uni, so that helped as well. And it was at that conference that we met, and I say we, me and a few friends, met a bunch of the connections and industry kind of links that still carry through to today. So who in this room is their first DDD that they've been to? Fantastic. It's probably about a third, which is really exciting because I'm excited to A, blow a few minds, hopefully, and hopefully in the right way, not hopefully in the crying, looking at my poor code kind of way. But no, I highly recommend to make sure you stick around, make sure you talk to as many people as you can as possible, because like I say, it's in this room, the community is relatively small. You'll notice that tons of people know each other. If you can break into those networks, introduce yourself, kind of show off what you can do and what you've done, you'll make great strides into the industry. But onto the talk, the lap around an 8-year-old payments company Codebase. So I actually sat down relatively recently and I kind of went down memory lane a little bit. I was going back through, and again, it's an 8-year-old company Codebase. I'm going back through and I'm trying to find examples of all the things I like and what do I want to show off and what patterns and procedures kind of interest me. And as I'm digging into the code, I'm coming across check-ins from kind of 2016, 2017. They're still there. They're still bolting together some of the really core aspects of the system. And that's both great and also scary that some aspects of this, and you'll see there's at one point in here a to-do that is, I think, my oldest to-do at about 8 years. So it'll get done one day. Don't worry about it. But it was this kind of nostalgic look back at the code that I had already created and built up over the years that got me kind of thinking about, okay, so what has stood the test of time? What patterns and practices are great? And I thought, okay, cool. I'm going to come up with best practices. And these are going to be, a set of rules almost, and a set of or rules of thumb, if you will, about what you should do, okay? But then I realized that, well, it's not really quite best practices, okay? It's practices. It's practices in the real world. And if you look back at the code, it's solid, but gosh, it grows and it evolves and it morphs. And I think one of the two tenets that I want to get across today is that, or two of the things that I value are simplicity is key. I think if you can do something in the simplest possible manner, don't over-engineer it. If it can be done simply, do it simply because that lasts. And let your systems evolve over time. Okay, so start with a simple thing and then add complexity as complexity is required. I think those are, look, if that's the only thing you take away from today, I think those are the two things that have really contributed towards the success and longevity of the product that I have. So, the agenda today is going to be full of things that I like personally. These are just the patterns and practices that I enjoy. I hope they resonate with you. I hope some of you get a laugh out of them as well. In the kind of bio / heads up about the talk, the idea is that to show juniors a few patterns that you might run into the future, to challenge some of the intermediate devs to kind of dial it down and don't explore every tech possible, just kind of build some solid foundations. And for the seniors, hopefully you get a laugh out of it. So I'm going to go through a few things. The result pattern, starting simple. Okay, it's just, are there any error messages? How do you bubble that up through a system? I'm going to be looking at DI and why I use DI, what it's for me. Okay, not the concept of DI, but just like what I use it for. I'm going to be looking at entity framework projections. Who here has heard of and or uses entity framework projections? Just curious. Okay, a few hands, that's great. I'm looking forward to that. This is, from a tech perspective, probably the best piece of advice I can give today as well. Going to be looking at the architecture. This would just happen to be the one we picked at the time. It's not good or bad. I'm just going to show you what it looks like. I'm going to be looking at backgrounding work. Okay, one of the first things you run into when you start building a web application is, gee, I need to do things, but not right now. What do I do about that? The very next problem you'll run into is, gee, I need to do too many things. How do I only do enough of them? And then finally, gee, I've done too many things all at once. How do I handle that? Finally, I'm going to take a look, this is kind of a stretch goal here, but if we can, look at the processing worker. So this is an in-order way to digest and do jobs. If you've heard of a saga or something similar to that, it's a critical systems thing, and it's pivotal to the company that we run because we have a bunch of financial data and we move a lot of money, and we've got to make sure that we move the correct amount of money to the correct place at the correct time. So with that, I'm going to flick between code and examples, just so that you can get an idea of things. Okay, so result pattern. It's as simple as this. I want to go do a thing, and I want to know what happened. Did it work or did it not work? And if there were any error messages, what were those error messages so that, and this is from the controller's perspective, what can I give back to the user as a result? Now, this is the real-world version of that, and it's inside of a post method. You can ignore the top bit. I've tried to dull it out a little bit. But effectively, I'm going to approach my service layer, which is the daily statement service. I'm going to say, OK, resend a daily statement. That's the job I'm here to do. I'm going to give it some parameters. And out of that, I just want to know what was successful and what was not. So now we can flick to code. And I'm going to hopefully, that's big enough, isn't it? Yes? Yeah, great, thank you. I'm going to just dive into, again, so bear with me. Hopefully this is easy enough to follow along with, but we're just going to go look at some real code. I've tried to pick some of the easier ones. So resend daily statement. The key thing is the service response, okay? That's the thing we're giving back. In the stack of services, so maybe I'm a controller, and the controller doesn't have any business logic in it. It's just calling through to the service layer. That service layer could be infinitely deep. I hope it's not, but it could be. How do we go all the way down and then collect all of the errors and surface them back up? It's through, I called it a service response because I didn't know the name result pattern at the time when I wrote it, but this is effectively how it worked. So we're in the service layer right now. Let's tee up the class, go do some validation, typically is the thing that happens first. Return an error message, or rather add an error message to the collection of error messages when you come across a situation like this where the data could not be found. Go and do some work, and you'll notice here that I'm also calling down into a further service. That service also returns a service response. I collect the error messages from that service below me. I add them just wholesale into my particular response, and then I return that up the chain. And if I go back into here, and I'm going to jump around a bit. So again, hands up if you lose track. The thing that calls that service layer that I was looking at is what we just looked at in the slide deck, okay? We're at the controller level, call the service, get a response, surface any error messages in JSON in this case because it's an API, or just return OK because there's no data return here. Result pattern, done. Okay, lovely. The next thing that I run into when I'm designing a web API and or any kind of concurrent system or system that has to do a lot of work is item potency. Who here is using some form of item potency at work? Okay, handful. Who here doesn't know what that is, just in case I need to explain it? Yeah, okay, a few. Item potency is the concept of being able to say, please do a thing, but only do it once. Okay, so the internet is very flaky. If I'm, for example, executing a credit card payment, I don't want to click the button and then have it kind of hang, and then if I want to click the button again, I don't want it to do 2 payments, right? I want it to do at most 1 payment. So what you do is you come up with an idempotency key, typically just a GUID or a string, and then you pass that along with your initial request, and then that way, if you pass a second one along, the system knows, hang on, I've already seen that key before, I'm not going to do anything. And what I will do actually to be helpful is I'll return the response of that initial request that you've lost or never saw, so that you can then continue picking up from where your process was after the fact. In this case, it's very similar to the result pattern. I've just got one extra property in there, which is an idemp or an n-once replay. And if there is an n-once replay, go ahead and give a 403 forbidden. I just picked a code, doesn't really matter. And pass the data back as well so they can continue. Now with that comes the very next question, which is, okay, great, but Ben, your API lets me submit multiple payments as one request. So rather than just like, hey, $200 please, I want to buy a ticket online, it might be, hang on, I've got 5 outstanding invoices, tick, 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 go. And so my idempotency request needs to cater to all of the idempotencies of those invoices. So what I actually do is take an array of strings as well as a string, and I digest them and I loop through, and if any of the keys exist, any one of them, I'll reject the call and I'll wind back the other ones. Otherwise, I'll lock in all 5 idempotency keys and execute the transaction. And that's what we're going to go look at now. Save real-time payments controller. I've got handy little notes. Let's go, yeah, save real-time the payments controller. Okay. So, we'll dive into like what this is actually doing in a little bit. But the thing to know here is that if we F12 into our DTO that we're receiving from the browser or the user, we have a n-once J token. Now this is how I do some tricky stuff to take in either a string or an array of strings. I cheat and I say it's just a J token and I go look at what it is later on. From there, that J token is iterated upon. If I go back to the payments controller, I translate the data into the next layer down. I'll get to that in a minute. I'm going to go into the save real-time payment method now. So we've moved from the controller layer into the service layer. I'm checking if I've been supplied with either a single string nonce or a collection of nonces, n-onces. I'm very sorry. If anyone knows what that word is, I didn't know what it was when I wrote this code. If you're from the UK or Europe, you'll understand. Don't Google it. So what we're doing is we're basically parsing that out so that we can have a list of strings regardless. That's up the top there. So we end up with a list of strings. Even if there's one string in that list, that's fine. And I'm just going to skip down to the n-once code here. But basically, if we've got any of them, what we're going to do is we're going to loop through all of the n-onces. We're going to check whether or not we have it yet. Okay. And this is where the benefit of hindsight comes in for the first time. So I did some fancy SQL to make sure that an idempotency key could be reused between user accounts. So rather than letting the database with a unique constraint tell me that, hey, you've doubled up on that value, instead I used fancy SQL to go, let me compartmentalize them. And I ran into all sorts of terrible deadlocking and conflictions and stuff like that. This works, but in hindsight, if you have merchant A and merchant B, and they both want to use the number 1, and they can, just put A_1 and put that in a unique constraint column, and B_1 in your unique constraint column, and you won't run into these problems. And then the database can tell you that you've had concurrency errors. So that's a handy bit of hindsight, but in essence, all we're doing is we're saying, please insert this key into the database. I won't dig into the actual SQL, it's not super relevant, but please insert this into the database. We'll get a result. That will be either, it's the number of rows affected, so that will be a 1 or a 0. A 1 if you successfully did it, a 0 if you didn't, and that key already existed. Regardless of whether or not it existed, I fetch the entity back out of the database again. This is literally just a, please go get it, where the key matches. And then what I do is I set up this response. I say, okay, is this the first entry? Great, you've captured the item potency key and passed that entity back. So this is the specific N1 service, and I'm going to go back up to the, okay, we're back in the real-time payment service now. We've gone one level back up. We've checked it. We've gotten our result. If it wasn't successful, remember that we're in a loop. What I'm going to do is delete all the other ones so that we can continue to process them. If it was successful, we're going to come back down here and say if it wasn't the first entry, go ahead and pull the data out of the database, set it against the response, set the nonce back on the response as well to let you know which one hit, and return that as a response. Otherwise, add it to your list of responses and keep going. So this particular piece here basically loops through that list. And then from that point onwards, you can go and safely process the request without the fear of doing it twice. All right. Item potency, check. Now, I will mention that I'm out the back in the middle exhibition stand here. If you want to see the actual code for anything that's going on here, if you have any questions about kind of the stuff I'm going through, and I know I'm going a bit fast, please come and visit me out the back, and I'll be happy to walk you through anything that you see today. So, dependency injection is the next thing I want to talk about. Now, this one is interesting because it's really just what do I use dependency injection for? For those of you who don't know what it is, it's a way of when you craft a service at the top, you say, here's all the other services I depend on, and you rely on some other thing to give you those services so that you can go use them. Now, I use dependency injection purely for lifetime management. And there's only really one use case that I really, really, really care about, and that's the database context. So you've got three different types of dependencies or lifetimes. Transient, which means that you'll get a service every single time you ask for it, a brand new one. Scoped, which means you'll get one, for the most part, per web request. So it's segmented into the current request you're serving. And singleton is there's only one instance of that thing. No matter where you request it, which web request you're in, background service, you'll get just that one instance. And that's good for shared state. So what I care about is this lifetime scope. Now, I use a dependency injection container called AutoFac. That's AUTOFAC. That's just my favorite one. A bloke called Nick wrote it. He's a legend, and he's very clever. Much more clever than me, and I trust him to do pretty much anything technical. So that project lets us create scopes. So what we've got up here is an inner scope. And the idea of that is if you've got a DB context, and you need to traverse or update or manage, let's say, hundreds of thousands of entities, what you should be doing is chunking up that call into sets of about 100, I find, is kind of a sweet spot for churning through entities with Entity Framework. And then what you need to do is dispose the DB context and get a brand new one and then roll through that next 100. And if you do that, you can get a very performant system because it chunks it up into something a lot more manageable for the context because it's not tracking too many things. And this is the way I like to do that. And what I will do is now, so this is the simple kind of version of that. I'll show you the complex version of that. Create payment batch in the scheduled payments processor. Excellent. Okay, I promise I will talk about the architecture. You get a bit more of a high-level view of what we're doing here so you can actually tell where we are. But for now, all I want to show is rolling through the creation of these lifetime scopes. So we're doing a bunch of stuff at the beginning. We can ignore that. One thing I do is use the top-level context. So undersource context is the web request scoped context. It's the main one that will be shared throughout all the services. I use that to go and figure out how many attempts I'm going to be dealing with. Basically, I loop through and I select out the ID, and in this case the currency, in chunks of 100, and I fetch the ID boundaries. So I say, for this chunk of 100, here's the bottom ID, here's the top ID. That way, when I do future calls, I can pluck out those records pretty quickly because it's on the primary key, and process them as I need. So I have a collection of tuple of int, that's where the minimum and maximum boundaries are. And I basically loop through, find all of the eligible things in chunks of 100, add those boundaries, and that's on the primary context. And then further down, and apologies for all the code that's surrounding it, here we go. We get to our for each. Now you can see some notes in there. At one point in time, I parallelized it to the processes on the machine, but that killed the database. The database is very much our bottleneck, so it can be run synchronously in this case. So we loop through our boundaries. What we're doing is we're going inner scope, please get me a new context. Well, first we're beginning a new lifetime scope, which is here. Then we're getting a new context given that inner scope, so it's going to give us a freshly scoped DB context. We use that context to go and perform the main query here, which is pulling out the entities that we can alter and save. I also have something that is pulling out a projection. This is so that I don't have to query tons and tons of data to do my job. I can just pull out the columns I need. We'll talk about that in a second. Because it was thread safe, I've got interlocked add to kind of count things, but effectively all I'm doing is looping through a bunch of stuff, updating some statuses, and then at the bottom here, going inner context.save changes, and that's it. So if we come back up to the using, it loops back around, does the new boundary, new scope, fresh database calls, and you can run that infinitely. That will just continue to work and work and work and work, no memory leaks, which is fantastic. So, dependency injection, there's a lot to it. I only care about lifetime and convenience, I guess is a way as well. All right, so projections, one of my favorite things. Now, I already asked how many people have heard of it and or use it. So the only thing a projection is instead of selecting the entire entity out of the database, we're just selecting the columns that we want. And we're doing this in a way such that we can just use normal link up here. And in this case, I'm literally just pulling the ID out of the payment object. And I'm doing it with an inline kind of projection in this case. That translates to SQL that just goes select ID from payments, effectively. That's what we want to do, but we want to do that on a grand scale. And to do it on a grand scale and to be consistent, I kind of also want to package those projections into something that can be reused and shared across the platform. And so what we'll do is we're changing out that anonymous lambda that was pulling out the ID, and we're using a reusable object here. And that reusable object looks like this. Now this is a very basic version of it. We're going to go look at the complex one. But it's a class, just a normal data transfer object, DTO. It's got one property, ID. And then importantly, it uses an expression of func of entity, comma, DTO that I want to send out the door, okay? So it needs to be an expression, so Link can read it without actually having to execute it. I typically put it within the class as well so that we can access some private properties. And we'll dive into that now. So I'm going to show you two examples of a single payment response. Of a projection. So this is a big one. This is what comes back from our database if you call get payment and it tries to list everything. So we get a bunch of fields. Importantly, there's things like this where you've got a private property that we can set. We can pull, in this case, it's an enum out of the database, just an int value. But then I want to use some C# to transform that int value into a nice, pretty string. But I don't want to feed that into the database. I want C# to do that. But I want my query to be efficient. So privately, I fetch the enum from the database. And then publicly, I use that value. I go do some stuff on it. I go get display name. And I can do that safely and quickly without affecting my database call. And we'll roll down here. There's a bunch of stuff you can do. You can fetch sub kind of collections as well. And I'm going to go down to the actual projection itself. And there's a few things to caveat here. So we've got an expression of func of payment to single response. This is my entity. This is the DTO I'm in, my projection. We return X arrow is new projection, and then we just map fields. This is going to call the database and only fetch the stuff that we ask for on the right. Importantly, you don't need to use any includes in your EF query because you can go ... and it translates it to the correct SQL query, so you don't have to go .include. It'll just do it by itself. You're not going to run into any null errors. This one here, by the way, is my 8-year-old to-do. So no, I can't do any better. Then you can do some things with dates and things like that. But importantly, the things I wanted to call out were that you can basically project single properties rather than collections. Normally to do a projection, you have to go .select and then put the projection in there. But that's not always the case if, in this case, I have a payment and there's only one payer for that payment and I just want to go .payer. You can still project that. I use a package called LinkKit, L-I-N-Q-K-I-T. That gives me the power to use this fancy expand property here, which then lets me pass in that single property. And under the hood, what it's doing is when EF, Entity Framework, is compiling the query for you and figuring out what it does, it uses a visitor pattern and it goes all the way and traverses the tree. It injects itself into that thing and goes, hey, you're about to do the wrong thing. I'm going to go grab that payer projection and slot it in for you so that you can have both collections come back as projections, nested infinitely, or single projections as well. And that is the secret sauce. That actually took me years and years and years to get to that point because the LinkKit project didn't exist, I've been using the precursor kind of blog post code that they had. And it never really just played nicely. So this is, if you take anything away from today, if you want to increase your database performance massively, EF Entity Framework projections. And if you just Google that, I've got a blog post on it as well. You should be able to find it. Right, that will do there. That will do for EF projections. Architecture. So again, I was going to, I want to kind of give you context as to our system and what we've done architecturally and then take a look at a few of the projects. This one I want to caveat that this is not the best way or the only way, it's just the way we happen to do it at the time. The thing I like about it, the thing that stood the test of time, is the separation of these layers has made it very easy to fall into the pit of success. Code that's supposed to go where it's supposed to go, you kind of know it's supposed to go there because all the other code around it looks the same and you don't run into any referential errors or anything like that. So it really guides you to the correct way. Now, what I'll do is I'll just show you the bottom layer there in an onion architecture. It kind of works its way in. First, you have your external interfaces. So in this case, like your UIs or your APIs or anything like that, that's that bottom layer. That code relies on the services layer, which is the next one in. So services never look outwards. Services don't know how the user is getting to you. They don't know how if it's JSON going back or if it's a web page or anything like that. They only know that they need to give data up. It's that UI layer that translates that and sends it back down to the user. So the UI layer goes to the services layer. The services layer then relies on your dependencies. So in this case, I've got a lot of SDKs, and then I have a data project and an email project. And then that data project holds all of our entity framework code, and that relies on our domain. And this was designed around the time that DDD, domain-driven design, not developer, the domain-driven design kind of gained popularity. It's in a similar vein, but my domain is just everything. And it's all in that one project. But it does contain every DTO, every entity, every concept that the system knows about is in that. And then all of that reliance flows down to it. And I think I was gonna, What I want to show about the onion architecture is specific to the web kind of framework, and it's just how we lay out, in this case, just the API. And it goes from request. Request will have a DTO that takes the data from the user and binds it to a class. That request then calls the services layer, and that services layer has its own DTO that you'll need to translate from the controller layer into the services layer, and that's important. 95% of that class will overlap between the two, but the authentication and security properties are typically what's missing from that request one. So if you're saying, hi, I'm user Ben, the outside world doesn't need to prove that. The request that comes in will just say, here's my data. And then when I go to the services layer, I can pass in the auth that says, hey, this is Ben. And then the services layer doesn't have to know about authentication. It just goes, oh, I've got a user ID. I trust it. I'm going to go do what I need to do. So we're in the services layer. The services layer can be infinitely deep. Typically, it's 1, 2, or 3. and that any of these layers can call the database and typically have a context in them. Once you've done what you need to do, gotten your data, transformed it, saved it, you can put in a projection, and then I pass the projection from deep in the service layer all the way back up to the response. So rather than trying to translate it, I try and get the services layer to do the projections themselves, because that's just more efficient, I think. So I'm going to show you an example of that. What do we post? Post in the payments controller. Okay. So here we are. This is the API endpoint for saving a scheduled payment. And I'm going to walk through those layers I just talked about. So we have the request. This is what the outside world is allowed to set. So you can set an ID, you can set some data about the payment and what you want to change. And you've got your N-once property there as well. If I come back up, you'll see that the request, if you malform the request, you'll just get null. So I kind of knew it up so I can send error messages back. But what happens now is I take the request model and I translate it into the options model. This is the service layer model that the services expect. And notably, it's mostly the exact same stuff, except for, in this case, who is the merchant I'm dealing with. And to identify that merchant, I'm just going to F12 into this. I'm in the base controller, so I'm in the ASP.NET world. And all I'm doing is, if you look down at the bottom return there, as I'm looking at the user claims, so the authentication server's done its stuff, and there's a bunch of claims on my user. And I'm just saying, who is the merchant ID from that claim? It's irrefutable, you can't alter it. It's cryptographically safe, so that ID comes back up in context. And we can just pass that down to the services layer. And then when we go into the services layer, we just trust, in fact, that's what half of our checks are, is that when we go to fetch data, we use that particular option to say, only give me data that's available to that particular merchant. So that's typically how this will work. We'll do some stuff. There's probably a bunch of validation and stuff that it's doing. It's not really important. Again, we're making some calls to the database to go alter some stuff. I'm sorry for flicking through this so quickly, but I just want to get to the bottom. So we've created or we've updated our entity. Oh, gosh. And actually, this is probably a good point. I like really big, long methods. So suck it, anyone that doesn't. Because I read code as a script. It's like a recipe. I like to see what it's doing and watch all the way down. When you have to jump around the place, it gets confusing. I like it long, but personal preference, don't take that as an endorsement. And we come all the way down, 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 down. All right, so this is the thing I wanted to show you. All of that work happened, and then because I said that I want my services layer to do the projection, I refetch the object, in this case, the single payment response. I refetch it from the database, put it into the data thing, and say, up you go. And that helps because that means that all the layers above me don't have to retranslate that to get it out the door. I don't have to give them too much data. I'm giving only what's needed. All right. Onion architecture, how are we doing? We're doing all right. I'm going to try and whip through these. Take a quick breather. I know I need one. Background cues. So, like I said in the intro, one of the first things you run into when you're designing an application is the need to do stuff later. So a request comes in, and the classic example is sending an email. You don't want the system to wait to know that the email is sent before it continues on doing its job. Maybe the only exception to that is maybe reset password or something that you expect to happen right then and there. But for the most part, if you do a thing and then you want to notify a user about that with an email, you want to do that later. So we say, right, throw that on a queue and have that something else sorted out there. Let's go take a look at what that looks like. Payment service 942. So, we're actually really close to where we just were. So after we've saved the payment, I kick off webhooks. This is something that is kind of common in web applications. It's not only do you show the user through the web UI that stuff has happened, but you want programmatically to tell other people's systems that stuff has happened. So I kick up a webhook. In this case, all I do is I say queue webhook delivery, I say go and do that, and then I continue on my merry way, and that's just literally returning down here. If we take a look at what it's doing, and we come into the queue webhook delivery, other than fetching the data required to execute that delivery, which is what it's doing here, mainly what it's doing is it's pushing a message onto a queue. And I'm going to get to that code now. So a queue here, sorry for jumping around, a queue client. This is an Azure storage account, just standard storage account. Has the concept of a queue in it. You can dump messages on that queue. It's mega cheap. And you can have Azure functions consume that queue. That is the simplest way to background anything possible. It's too simple, in fact, because you'll run into problems. But all you need is a queue client, which you give it a connection string, and you give it a queue name, and then you can start passing queue items to it. So if I come down here, went past it, sorry. Send message async. It's just some JSON. It's very lightweight, importantly. You don't want to put too much into a message. You want it to be nice and small. Off you go. Do the thing. That's as simple. That's as simple as it is, okay? What happens then is throttling. So very early when we started backgrounding tasks, we had imports to do. So we took a big CSV file and we went, okay, cool, we're going to import 10,000 payers into our system. Let's do that. CSV upload go. And then all of a sudden our queue goes whoosh, and our Azure function goes, great, I'm like really lightweight, I'm just going to power through it. And our database gets smashed. And the retries, we had the default 5 times retry on. So the retries start smashing. And this completely collapsed the system. It absolutely ruined everything. So what do you need to do? You need to throttle. Now this is where we take a look at inbox and processing queues, okay? So what I'll do is I'll give you the gist of it. You have an inbox queue, which is a standard queue, and you can dump as much as you want into that. Then you have a thing in the middle that decides how many messages need to be run, and you have a processing queue that will run messages immediately. And so the idea is that the thing in the middle just goes, okay, it's time, processing queue, and now, and now, and it drip feeds it into the execution queue. Now there are systems out there, I'm sure, that let you do that in a much more efficient way. But what I wanted to do, well, not wanted to, I had a requirement, and I'm just going to show you the conductor because I'm going to run out of time in a minute. I'm going to show you prod. Let's see what's going on in prod. Okay, so I have a system that takes a number of requests, and importantly that's requests, not messages, number of requests per minute, and then it throttles based on that. And it can take a number of queues. So for example, if I come down to this one here, the HubSpot throttle, they only like us sending 60 requests per minute to the HubSpot. I've got 3 different queues that I like to queue messages up onto to go do HubSpotty things. So I take all 3 of those and I say, at most, make 1 call to HubSpot at a time, well, 60 per minute. But I need to group that by merchant, because every single user of HubSpot has their own 60 per minute to be able to do this. This is where the like service busy stuff kind of was too complex, and I went, right, I'm just going to make my own one of these. And so the thing, all it does is it says, hey, consume all the messages in the queue, and I might actually just run through the code. All right. So I'll go just one above so you can see what it looks like. Okay. I don't know where HubSpot's going, but he's in here somewhere. Here we go. HubSpot app throttle. Oh no, HubSpot internal throttle. Oh, it's a secret one. Okay, so here we have a throttle, 60 requests per 60 seconds. Here are the list of queues that I want you to monitor and deal with. There's some connection strings. I've got a whole lot of these kind of, I call them conductors, but like a whole lot of these like mediators doing this thing. And I await all of them at the bottom here. Oh, quick tidbit. If you've got a whole lot of tasks and you want to wait till they're all finished, it's really tempting to use when all await task.whenAll. That's a terrible idea because if one of them fails, it doesn't return. It waits for all of them to complete or fail, and because this is a long-running process, it runs forever, you'll just realize that parts of your system stop running. So you use whenAny so that you can capture any failures and then reboot the system if needed. All right. So the conductor, what it does is it boots up, it initializes any queues that it has access to, so that's the 3 queues for the HubSpot one. It shuts down gracefully if a cancellation token is received. It collects some statistics about what's going on. That's this screen here, where it's putting these numbers in and any estimated time remaining. It holds here in these buffer queues. It purges those queues if they get to 0. What it does next is and I apologize, this is quick, it fetches messages in batches of 20, and then it reads through those messages to see how many calls are inside of those messages, because one message might have 10 calls that it needs to make. So it'll fetch all those messages, it'll add some stats to in-memory, it'll show some status updates if it needs to. It collects these stats and publishes them to a Cosmos DB. That's what this screen is looking at. It's just effectively a big table that sits in Cosmos, and I just constantly delete it and refresh it. If we keep going, if there's no messages in the list, log a little heartbeat, delay, and then loop. Otherwise, whilst we have messages, go ahead and try and pull them out of the queue. Get rid of any that have expired. Work out the total number of calls. I do that using waits, so one message might have 5 calls. That's a wait of 5. Check whether or not we're within our throttle limits. So this is where the logic part of the conductor comes in. What are the total calls we've got so far? That's a sum. What's the weight of the next one? Is that less than the limit? Great, we're within the limit. Same for groups, same for concurrency. Basically, if we're within our limits, go ahead and push it to the queue. This call here is exactly the same as the one I showed you before. It just says, put that JSON on the queue. What we do is we add basically to our buffer, we increment the count. If there's no messages to do, it basically goes and checks, how long is the delay. Sorry, not if there's no messages to queue, if we're not within our limits, so we've hit our limits, what do we do now? Basically, we take the message that's wanting to be called, we figure out when it's going to actually get done, because if we're the 10,000th message, we're not going to get done for a while, so we want to know when it's going to happen. We put a visibility date, we kind of work out when we want it to run in future, put a visibility date on there, and then we re-queue it back into the inbox queue with a delay. So the pros and cons to that are that in the inbox queue, rather than just kind of waiting and then only popping off messages when we're ready, I churn through the entire queue so that I know how many calls are in it and I can report things back properly. The downside to that is that I'm re-queuing back on top, so it doesn't guarantee order because something might come in halfway through me doing that, which doesn't matter to me because the queue's designed to be fast, but that might be a problem for others, so I just wanted to warn you of that. And that's effectively it in terms of a conductor. I don't have time to go through concurrency, but effectively, the one thing that you'll run into next is that if you have 1,000 messages all pointing to the same merchant, and that 1,000 messages might be doing the same thing sometimes, it might be doing different things sometimes, you need to lock something. And in my world, concurrency isn't thread safe. It's not, can I lock an object in C# code? It's, I might have a web server over there, I might have a UI user over here, I might have a background process over here, and they all want to do the same thing at once. So concurrency is just something's coming at you from anywhere. So the way I do that, and I will just briefly, can I see that? Apologies to the timekeepers. Just because it's cool, it's really cool. Lock. What was it? Stripe service. There you go. Thanks, guys. You've helped me out. And then create update. Oh, is it 1 minute? Okay, never mind. There's a locking service and it's great, trust me. If you want to see it, come see me afterwards. Oh, here we go. No, it's right here. Look, concurrency service. Ha, that's what it was. Has lock. All we're doing is we see if there's a processing lock on the entity, you need a byte column, you set a GUID in there, You need the timestamp column so that the database can tell you when you've updated things twice. You check for a lock. Thank you. You check for a lock. If you can capture the lock, all you're doing is setting the GUID and setting a timeout. That's probably important as well, so that if something goes wrong, you say the timeout's an hour later, and then it'll just blitz the lock then. Anyway, the final thing I wanted to say was just we are currently growing this year. We're looking to do a hiring blitz throughout the year. We also want to begin our junior track. One of the goals I have for the company is for someone else to look at someone's resume and see Pinch on there and go, aha, I know them. They're great. I trust that this developer knows what they're doing. So we're going to try and start putting a little bit more effort back into the junior track. We've got some exciting stuff coming up. We've got a brand new checkout process that we're working on with all sorts of cool, payment plan interesting things in there, and lots of really cool, interesting payment infrastructure problems that we're working on. So if you're interested in talking to us about a job, come get me out the back there. Make sure you play bingo and win a prize. I think we're adding a giant Milky Way Lego set as well to the prize pool, so that's another thing to win. Thank you to all the sponsors. Honestly, it's been a real privilege to be the primary sponsor this year, but every dollar helps. And if you're able to convince your workplaces to contribute to an event like this, it's very cost effective and it's very helpful to the industry. And that was a lap around our code base. Thank you so much.